Hi everyone, I'm Phil from Statistics Mentor. Today we're going to be considering this problem, counting the number of ways to choose R objects from N number of objects where N is always bigger than R. This kind of problem we encounter when we're dealing with probabilities. Let's give a quick example here. Suppose I have three objects. Let's just label them A, B, C. Okay, we might wish to select from three objects two objects. So in this case we have a problem where we're trying to choose two from three. So N3 because we've got three objects, and our problem is to select number of ways to select from them two of them. Okay, just to give you an example here, I could select AB, that's two objects. I could select BC, that's another two objects. I could select AC, that's another two objects, and so on. Now, the number of ways that we can select R objects from N depends on, is repetition allowed? That's going to be yes or no. By repetition meaning that, can I select the same thing that I've already selected? So if we go back to the example, I rubbed it out. I didn't need to rub it out. Suppose I got A, B, C. So suppose I selected A. If repetition is not allowed, I've selected A, so that's gone. I can only select B or C. However, if repetition is allowed, I can select A again, even though I selected it before. Okay, that's what I mean by that. Next, is order important? So if order is important, something like AB, say I select 2 for AB, would be different to BA. These two things would be different. But if order is not important, these two things are counted as one because they contain the same members. Now let's give some names to these things. Where we are talking about choosing R from N, repetition is allowed, and where order is important, we call that a permutation. Just put P, that's it, P for permutation. How about where repetition is allowed but order is not important? We call that a combination. No doubt you have heard these terms in your classes. Where repetition is not allowed and order is important, that is a permutation. Permutation. Where order is not important and repetition is not allowed, that is a combination. So look carefully now and see if you can spot any patterns between what is a permutation, what is a combination. Okay. The difference between a permutation and a combination, clearly from this table you can see, is that in permutation the order is important, because look, where order is important, whether or not repetitions are allowed, it's permutation. Where order of the outcomes is not important, whether or not repetition is allowed, yes or no, is combination. So to put it in a nutshell, where permutation, order of the outcomes is important, whereas for combination, order is not important. I'm just trying to give an overview here, so I'm not writing down any formulas at the moment. I'm just trying to understand this thing. So think about it. If we have the same problem, say if I want to choose 3 from 2 using combination, and 3 from 2 with a permutation, whether or not repetition is allowed, which should give a bigger number? The answer is permutation, because order matters for permutation. So if we go back to the first example I gave you, AB in permutation and BA in permutations, they're different things. They're counted as two distinct things, whereas if it was for a combination, they would be counted as one thing. So for the same kind of N and R for permutations and combinations, it's always going to be the case that the permutation should give you a bigger number than combination. Okay. I haven't actually planned this lesson, so I'm just talking top of my head. Let's see, what else can I say? The other thing is, note that on your calculator, by default, the calculator for the permutation gives you the case where there's no repetition. So it gives us for this one, it gives us for this one, as I show you later on using a calculator. Now, let's fill in the formulas then. Okay, repetition is allowed, order is important for a permutation for selecting R from n objects. The formula, the equation is n to the power of R. You can think about these intuitively, but I'm not at the moment. I'm just writing down the formulas. Now, where repetition is not allowed, an order is important. That's a permutation, and that is given by n factorial over n minus r factorial. Where repetition is not allowed and order is not important, that is a combination, and the formula here is n factorial over n minus r factorial times r factorial, which can also be denoted open bracket n and then r below that, like so. I've introduced the notation here because I want to use it for the final case. Repetition is allowed, order is not important. Here the formula is n plus r minus 1 over r, like that. Okay. Now, from the courses that I've taught, often is the case that we deal with the case where repetition is not allowed, so that's why you'll see a lot of the time in the lecture slides they talk about on the exercises, you see this one you might apply and then this one, but then some students think, hey, hang on a minute, we've seen at school or something where repetition is allowed. Okay, well, yes, they are allowed, and the formulas are slightly then different, but most of the time it appears we're using this one and this one. And out of these two, in problems, it's typically this one we use. Alright? And as a side here, if you look at this and think about a probability mass function for a discrete random variable, you might have recognized this as being part of the probability mass function for a binomial distribution. Let's recall that when x is binomial, you remember seeing this? PR1 minus Pn minus R. I'm talking about this bit here. This is counting the number of ways, combination. Okay. But that's for another time, that's not. Okay, I want to talk about next about notation for permutation and for combinations. So you'll have seen variously it written like this, like so, or like this, or like this. For permutations, that all mean the same thing. Combination, you'll have seen it typically written like this, like this, like this, or like this. Okay, they all mean the same thing. From n objects, choose R. Right, so I think that's in as far as I'll go in this video. I'll continue in another video giving you an example on using permutations and combinations, but the main result to come from today's session is that this problem of number of ways of choosing R from n depends on is repetition allowed, and I explain what that meant. Order of the outcomes important, I explained what that meant, and then I introduced the terms permutation and combinations, and we gave the formulas as well for each. There are 4 cases here. Alright. In terms of the ways of counting, there are actually some other ways as well, but here we've been talking about permutations and combinations since these are used most often in our introductory courses. Okay, I'm Phil. See you later.